Okay, so let's go ahead and get going. So just to give you a quick lay of the land, I'm going to go start on the first little bit and then turn it over to Haley, and she's going to cover the sort of last half of things. And so to start, I think the first thing that hopefully folks have done is installed your R in RStudio. And so I'm going to walk through the lesson that's essentially getting started over here, and a little bit touch on project management, and then we're going to jump into getting data in and playing with it. Okay. So sorry, there's some background noise going on right now in my house because I have children. So starting up, let's do get started. And hang on 1 second. Thanks. I just want to jump in about using R for bioassessment data. Like, why are we doing this? R is really a statistical computing language originally, but it's become one of the main languages that you can do a whole lot of things. Like, this entire website is built using R, which is awesome. So there's a lot of things that you can do. You can visualize things now. And so it's a really powerful and open source. It's free, no matter where you are or what computer you're on. Ideally, you probably are going to be able to install R and RStudio and use them. So it's quite flexible, and it's become really a powerful tool, particularly in science right now. So I think, as with many programming languages, R has specific benefits. I think it's a little easier to learn than Python or some other languages you might hear about. But having said that, it's still a programming language, right? So it's still learning a new language. And as with any language, it's something that requires a lot of repetition to use. So this workshop is mainly to sort of break the barrier of like getting going, which can be the hardest thing, to sort of show you that it's not crazy hard to just get going on some simple tasks. And really, if you kind of force yourself to use it as much as you can, it does get easier. Okay, so open R in RStudio. So the first thing we're going to do is I'm going to go ahead and walk through navigating RStudio a little bit. So I'd like everybody to open up your RStudio. Mine looks like this, and I'm going to show you how I can change that a little bit with, hopefully people can see my whole screen here. Hang on 1 second. There we go. All right, so when I open up RStudio, there's a few things that you're going to see. This is the script I'm going to be working in, right? But I want everybody to go to Tools and Global Options. One of the first things we're going to do is we're going to take a look at the settings in here. There's a couple really important things that I want to mention that are really important just for general data science. And the most important one, I would say, is this here, where it says Workspace. Mine is not checked, and yours likely is. I would like everybody to uncheck that and to turn this to never. And I'm going to explain why. So when you open up RStudio, which is opening up R behind the scenes, so RStudio is like you're driving the car, and R is like the engine, right? And so what happens is when you are using this workspace option, when you close out of R and RStudio, it saves everything you've done into just one file. And the problem is then it can also bring that back into your workspace when you open everything up again. And you don't necessarily know what you've done to that data. You don't know how you got it. You have no sort of record other than you've just got this glob of data and things in your workspace. And that's not really how we want to teach you all how to do things. We want this to be reproducible. So the whole point of sort of working in this RStudio environment is that I can do something and share the code with you, and you can rerun it on your computer and generate the exact same thing, which is amazingly powerful and is ideally where science should be headed towards, right? Being reproducible. And so, or even tasks that you do all the time, it makes it much easier. So you always want to start with a clean slate, right? Because you always want to know exactly what you're bringing in and exactly what you're saving out. And so that's why this default setting, I would say, is the one main knock on RStudio, and many people have talked about why it's not great for a long time. So go ahead and uncheck that and click never, and you can click apply. And then the other thing you're going to notice is there's a bunch of other settings in here for appearance, code, general. There's a whole bunch of things. You'll notice my background is black, and I have some kind of colored code in here. You can easily change that to you know, light. If you wanted to make this a white background, it's quite bright. I tend to like the darker backgrounds. It's a little easier on my eyes personally. So you can change that however you like, switch it as much as you like. It's quite nice. The other main thing is the panel or pane layout. So you'll notice there's sort of 4 squares. I have mine set up just because teaching is a little easier when I can have the code on the left here. So this is my script or my source, and the console, which is essentially what is being sent to the R interpreter, like what code is being run, I put that on the right. But you can switch these around however you like. Typically the default is to have the source and console on the left side like this. You can switch these, again, however you prefer. I'm just gonna let you know my setup currently is gonna have the source here and the console here. Haley might have a slightly different setup too, okay? So it's good to sort of navigate to where things are in R. Okay. Any questions on that, please go ahead and throw them in the chat, or if you have any issues with getting this set up, please put a red no next to your name and the participants. That'd be really great. Okay, so let's jump into actually doing some of the setup. So one of the other great things about R and R Studio is we want everybody to use a project, okay? And so inside of R, one of the cool things is they have this thing called R Studio projects, which are essentially a nice way to stay organized. And so now I just want everybody to know, again, I am gonna show you where I am on the website. I'm now jumping over to the first lesson, importing data, okay? And we're gonna talk about sort of setting up a project and getting organized. So, but I'm gonna stay in my R Studio. So in File, you can go to New Project here, or you can click on this little button over here and do New Project. They're both the same exact thing. So if you go to New Project, I'd love everybody to, oh, it's not letting me do that right now. Try File. Oh. Hang on.
No. It's on the Google Doc, and it says CI Kadang.
I can't. Hang on. I'm gonna stop the screen share real quick and switch the way I'm doing this, because maybe it has to do with that.
I'm not the supervisor for AES, so.
Okay, here we go. Trying again. Thanks for your patience. Okay, so hopefully everybody can again see my R Studio screen on the over here. And so I'm gonna go to File, there we go, New Project. And it takes a second, but here we go. Here's a new sort of options. You can use either new directory or existing directory or version control. Today, let's just do new directory. And let's go ahead and use a new project. And then let's go ahead and name this. In the lesson, I believe we have this, we'd like you to name this as, what do we call it? CABW-R Workshop, okay? So go ahead and name it. And notice there's underscores, no spaces. General rule of thumb in computer science and programming, you wanna avoid spaces and any weird characters. So I'm gonna paste that in there. And then you can put this wherever you want on your computer. I would say, typically I keep each one of these as an R project and largely all on GitHub. You can put it wherever you want. Just try to keep it in a contained place. And the other thing is you never wanna nest sort of projects within other projects, R Studio projects. So have one big folder, if that's documents, great, or R projects, great. And then within each of that, each folder will be its own R Studio project. And so I'm not going to create this because we already have one we're working in, but you're going to click on that and it should open the project, and it'll bring up a brand new fresh sort of project here. And so once you have done that, please go ahead and put a green in participants. Go ahead and put a green yes. Awesome, look at all those green yeses. And if you do run into issues, please put a red no or a go slow or something, and our helpers can follow up with you. Great, I like all the green checks, that's great. Okay, so let's go ahead and move to the next step in this, which is going to be scripting, right? So now we have a new project. And the awesome thing about these projects is everything is contained within this. And you'll notice in the setup, there's a lesson over here on project management. I don't have time to go through everything, but I would highly encourage every one of you to take a look at this, because one of the biggest issues with programming and just working on computers in general often is like, where are you in your computer? So as we move forward today, one of the biggest common issues that comes up when and it still comes up even when you've been using R for a while, is locating files, and sort of the way the computer sees a file versus the way you see a file might be quite different. And so there are a few sort of really important habits that you can make. And one of them is always being aware of your file paths, right? So we're working inside a project, and so everything is relative inside that project. And so I give some examples in this project management lesson about how you can sort of use these relative links as a way to make sure that things are where you think they are. And the other advantage is they won't break if you send it to someone else, right? So again, reproducibility is really the power of this type of workflow. And so you want to make sure that you're not having a specific, path that is in your code that will only work on your computer and may not even work in the future if you change a file name or a folder name. So relative links are really massively helpful. Jenny Bryan has a really great, excuse me, a really great, where is it? Slides you need to read. I highly recommend checking that out about file naming as well. It's really helpful. So again, I don't have time to sort of go through this in detail, but pretty much assuming from now on we're using relative path names, and I'll explain, we'll see how that works in a little bit, okay? Okay, so back to our code here. So we're in the first lesson, importing data, and I'm gonna go down now to scripting. So I'd like everybody to go to either this icon where it says new file, or you can go to file, new file, and R script. And go ahead and make a new R script. And what will happen is you'll get this new thing that says untitled. And what we wanna do is go ahead and save that. You can save that as whatever you want. But I think one of the most important things is inside your project, and this goes to the new sort of relative path files path names I was talking about. Every project that I use, I always create a code and a data and sometimes like a docs folder, right? And that means that I can switch around between any given project on any given day, or even multiple at once, and I can know exactly where everything is. I know where the data is, so the raw data goes in data, and I know that my code to work with that data goes in the code folder. And so if you do that, then it makes it quite easy for you to use these relative path names. So I'll go ahead and just make a new script here. And I'll call it new script day 1. Again, underscores, not spaces. I'll save that. And so the other thing you'll probably have to do, if you find your files tab, you can actually make folders right within this, this window. So if you click new folder, you can make a data folder, right, which I've already made here. And same thing, you can make a code folder. Some people call that scripts or R. Whatever it is fine as long as it's consistent. So between projects, if you switch to another project, you use the same sort of terminology across all your projects. Just makes it easier for your brain space to switch into a new project. Cool, all right. So let's go ahead and jump into variables. So we have a script now, hopefully. I'm gonna be working in this one. And R, basically anything you type in R, if you put a pound or hash sign in front of it, it's a comment. So it's sort of a message to yourself. It's not interpreting that. So anything I type here is a comment. And comments are really important, right? They are the thing that helps you interpret your code. Your future self will thank your past self for writing comments about what you are doing. So for every little line of code, it might seem a little tedious, but it's really helpful to write what it is you're doing. And so almost every script that I start, I always put sort of what it's doing, right? So this is day one, R workshop. Another really cool trick that you can use, if you're on your, actually it doesn't really matter, if you're on a Mac or a PC, if you type Control-Shift-R all together, so I'm holding down Control, holding down Shift, holding down R, you can add a section label. And the really cool thing about section labels is they're sort of a way to make an outline of what you are doing. And so we can say day one workshop. And now you'll see this kind of, I'm gonna delete this one. You'll see this thing that has a comment and then a bunch of hash or hyphens in front of it. And the other little thing, you'll see this little arrow. So that means anything I put below this until the next section, I can minimize. I can sort of squish it all into one chunk, which is quite nice. The other thing you can do is you can use this little button over here, which is kind of hidden depending on your screen space. And that will allow me to flip between sections, right? So why don't you all go ahead and make a section, make two sections. We're gonna have one that's the day one workshop, and then the next one is, let's call it, and again, Control or Command Shift R to make a section label. And let's call this basic R. There we go. So now you'll see I have two sections and I can flip, you know, if my code was really long, I can click on these and flip between sections. And this is a really nice way to stay organized and keep your code sort of well labeled. And so I'm gonna hide that, okay? Okay, so variables, I'm gonna jump right into that, variables now. So in R, we can say a variable is something that is assigned using this little caret and a hyphen. And I believe you can, the shortcut for that is Alt hyphen maybe. I'm not sure. I type it out. If you don't want to type it out, that's understandable. There is a shortcut. There's a shortcut for everything. So anyway, that is basically this format is the way to sort of say that this object is going to be assigned with whatever I put on the right side of it. And in this case, R can act like a calculator. So I can say that fish is equal to 10 plus 45. And to evaluate that code or run that code, you can do two things. You can click this button here and it'll run it. And now you'll notice I have over here in my console, suddenly this shows up. And the other thing is in my environment, I've now assigned a value. Fish now has a value of 55, okay? So that's how you assign something. And if I wanted to run this without clicking a button, the shortcut is Control Enter or Command Enter. On the line that you're on, it'll run that, just that line. And I can run that over and over again, right? And you can see it over here. And so here's that value. And so that is a really helpful way to run the code. We've got that shortcut in there as well. And so that's sort of how you run code in R, right? Okay, so let's go ahead and add a couple other things here. I'm gonna comment, right? So add additional variables, and we're gonna add nitrogen. And again, this could be whatever. This is just a demonstration to sort of show you how you can add these things. And again, I'm hitting enter and no code is running. I'm just putting this in my script and saving it, right? But now the cool thing is I can use what I've already entered. So again, we have this fish value in our environment. I can now call that fish value, and you'll see I typed that in and that popped up. And the cool thing about R Studio is tab autocomplete. So if I just have F and I type I, you know, a bunch of things pop up, and then S, suddenly fish shows up. You'll see it has a little purple kind of rectangle next to it. If I hit Tab and Enter, it fills that for me, which is awesome. Okay. Autocomplete is your friend. It really helps with typos because R is case sensitive and so spelling sensitive as well. So that is an important part of it. And again, nitrogen, again, I can hit Enter and it'll add that. And so I need to run this before I can run this. Because if I run this, let's see what happens. Error, nitrogen not found, right? Because I didn't run this line, so it doesn't exist in my environment yet. So I need to run Control Enter. And algae now we see is the product of fish times nitrogen, and you get algae. Okay. All right. So I'd like you all to take a quick sec to do this practice set, which is here. Let me show you. I'll put it back on the screen over here. So we do this practice set. Please create variables riffle and pool in your script and assign a number to each. Okay, and then annotate them. I'm gonna give you like 30 seconds to do this, and then we'll click for the answers and move on. Okay. I know this seems simple, but we want to make sure everybody's on the same page about how all this works, and we're starting from the very beginning. Okay. All right. So go ahead and do that. And then we're going to jump into installing or not getting our data into R. And then I'm going to hand it off to Haley. We're running a little behind. Well, no, actually we're okay. I can't see anyone, so, you know. How are we doing, Haley? Good? Okay. Awesome. All right, so I'm going to jump back over into, let's kind of walk through what that challenge was. So in each of these little challenges, I know this seems really silly and simple, but I think it's really important to do on your own and feel like you've accomplished a step. So if you click on this little green box, it'll drop down and show you how to do this, right? So I'm going to copy and paste this for the sake of time. So you can copy with Control-C or Command-C, and then go back over to my code, paste with Control-V or Command-V, and there we go. So now I've got riffle, and in this case, I made it 100. And then a sort of a tricky addition here, you could just do a single number, but if you wanted to make a list of numbers, you use this C format, and we'll talk more about that in a little bit, but anything inside of that is short for combine or concatenate. I've actually seen both. But this is a way to now assign multiple numbers to one value. So pool has now 3 numbers in my environment, okay? Awesome, and then we can save our script with Command-S or Control-S, or File, Save. And one thing you'll notice, our studio is pretty smart. If I do some typing, type here, you'll notice at the top, this code is now, it's blue, and it has a little asterisk next to it. That means it has not been saved yet. And so that's kind of a way of you visually seeing like, oh, I should save my code. Okay, and when I save it, I'm gonna hit Control-S, Command-S. Now it's white, so it's saved up to the current moment. So that's a good way to see kind of where things are and if you've saved your code. Okay. All right. So let's jump into. So this is the next big hurdle to get over, and then we're in the clear, I think, for a few things. So I'm not going to walk through, or I'm not going to install each package because hopefully we have already done that. But I will show you the code required. So I'm going to make a new section. Control-Shift-R. So install packages. So most of you, I think, were able to do this, and if not, no worries. Again, we can use the RStudio Cloud or kind of let this wash over you, and we'll follow up at a break. But the main packages that we are going to be using to install a package in R, there's 2 ways to do it. So we can use the code, install.packages. So this is a function. So a function has basically anything with parentheses is a function, and there's arguments inside that function. And so in this case, it wants to know what is the argument, and it wants a package name. And so if I wanted to install the SF package, which is a spatial features or simple features package that does spatial data, I would use quotes here, and then I would run this code. I would hit Command Enter. I'm not going to do that because I've already installed these things. The alternate way to do this is you can go to Tools, and then you'll see Install Packages. And if I click on that, I get, it might take a minute. And if you haven't used this before, you might actually have to specify what repository, which is basically like where these things all live. And they're mirrored all over the world. So there's lots of different repositories. And you might have to do that. But again, you could type in SF here and click there and then hit install, and it would essentially run this. It's going to run this exact line of code. The nice thing about this is it lets you search kind of as you're going, and you can see there's like tens of thousands of packages actually. So there are a lot of packages that you can use, and these packages are essentially sets of functions that allow us to do all kinds of things. And more often than not, I will just give this advice early. Oftentimes people have already written a package or a function that does what you want. It's just finding it. And so sometimes I have literally seen someone who has written a custom function and then they find the package that does exactly that afterwards. So do spend a little time poking around sometimes, and we'll show you some resources on how to do that. Actually, they're in the, I'll flip over in setup. I think in getting started, we have a whole slew of sort of package options of how to look for packages, additional resources, but in particular, the CRAN list here, there's a bunch of different help groups, and these are good places to search for packages or look for help. I'll talk a little bit about Google and Stack Overflow really quickly. So blind Googling is great. I still Google stuff all the time. It's totally okay. Please do it. Take advantage of it. That's how you learn. And so, and I'm sure Haley is nodding her head, and everyone who has learned R, like, you survive by Googling. So there is no sort of like, I've never met somebody who just knows everything, and I mean, even Hadley Wickham, I'm sure Googles stuff. So, so anyway, there's a few tricks to it though, I would say, and we lay some of these out here. Prefacing your search with R is really helpful. So doing sort of brackets R or R plus, something like that. And then kind of getting a sense of what sources are reliable. So we mentioned Stack Overflow here. There's some RStudio has its own community webpage here we link to, which is great. It's another place to search for questions. And so, you know, keep in mind a few things, particularly the date when something was posted. Things change and there's lots of updates. So try to find a more recent response to a question. Sometimes searching the exact error message is really helpful as well, okay? So even installing packages, this comes up, you might run into an error. You can Google, you know, copy and paste that error right into Google and send it in and see what you get, okay? I will say, do be cognizant that I typically, and I think Haley is in the same boat, and a lot of folks, I use Stack Overflow to search for answers. I don't necessarily go and post questions there. It can be a little less than friendly community to post questions to for various reasons that I'm not going to get into, but I would say the supportive, really warm, welcoming communities tend to be like the RStudio community. R Ladies is great. There's a lot of sort of local groups, I think, that are a little more friendly to open to questions. And so you'll just be aware. You might see some kind of snark in the world, and take that with a grain of salt. So, all right, so let's jump back over to importing our data. And so I am going to assume, which is never a good idea, right, that folks have already done this. So if you've already installed these packages and the tidyverse, I'm going to jump into the next step, which is today. Right now, we're pretty much only going to use the tidyverse. So I'm going to walk over to my script here. I'm going to comment this out. And I'm going to make a new section, Control-Shift-R, loading libraries. So I almost always put this at the head of every script that I do so people can see what libraries I'm using. And in this case, library is a package. And it's a little confusing with the way they've sort of termed these, but the library is, think of a library of functions, right? It's essentially a list of all the different things that exist that you can use. And you load a library once per session. So every time you open up R, you're gonna have to load that library, whatever library you're gonna use, so you have access to those functions. It's like a spell book, right? Like a cookbook. Every time you cook something, you take the cookbook down, you read the ingredients, you need that recipe. You only need to buy the cookbook once, and that's install packages is the once time, right? So you're only installing one time per sort of R install, or what is it? Sort of every time you install R or update R Studio, that's when you need to install the package. Okay, so I'm gonna use library tidyverse because I need to load these functions so I can use them. Command Enter. And what you'll see, hopefully, is kind of a bunch of messages here that you might notice have, there's a few things to pay attention to. It's saying that it's attaching all these different packages. All of these are part of the tidyverse. So each one of these is its own package or library. And then there's a few conflicts. Don't worry too much about that. What that means is that there is already a function named filter in the stats package, and there's a similar filter in the dplyr package. That doesn't mean that you can't use either of those. It just is letting you know, hey, there's two things that are named the same thing. And this will pop up and just give you a heads up. But overall, this worked. We didn't have any error messages. We ended up back with our little caret symbol here, which means that there was no error and we're back to being able to enter data, okay? Awesome. So now let's get some data into R. And so if you had any issues with the getting tidyverse loaded, go ahead in the participants. If you can please put a little red no, that'd be great. Okay, so we're finally getting to the point where we can actually work with some data. What I want us to do now is hopefully we have grabbed some data, but if not, I'm going to show you exactly how to do that. And we've made a data folder in our project, okay? So we're going to, on the website, there's two places you can go. In the lesson we are currently, we're in importing data and getting your data into R. I'm going to go to this link, data are here, or you can go to resources and lesson data sets, and you can download this as a full zipped folder. That's what I'd like everybody to do. So if you click on that, yes, that's going to download to downloads. And then what I'm going to do is find on my computer that went to downloads. So I need to now, in downloads, wherever that went, I'm going to take that data zip here, okay? And I'm going to put it, actually now I need to open, one other trick you can do is in files. So there's a bunch of little options here. Under more, you can actually show folder in new window, and that will open exactly wherever you put your project on your computer. It will open that folder. So you can see I have a our project. There's a few other files in here, but I have code and data, and I'm gonna drop the data into data. Okay, and then if I look in there, now in data I have this. Now I need to unzip this, and I think I'll just double click this on my computer. Some folks might have different options to do this. Okay, so now we have these 3 files, and I want all of these 3 files to live in my data folder. I don't want them to be in data zip necessarily because that'll make things a little tricky. So I'm going to move them all into data. So everything is now in data, okay? And I'm going to delete this data zip folder that is now empty. Okay, so green check if you now have in a data folder these 3 pieces of data, these CSVs, because the next step is importing them and then moving on. So green check Once you have that,
I gotta go kick my son off the video games. I'm pretty sure.
and hang on one second. Okay, as I see, about half the folks have green checks. There's some more green checks showing up. Awesome. All right, so let's go back to our lesson and jump into the part where we're gonna actually put some of that data into R. We're gonna figure out how to do that. And so we loaded our library. We have our project. We've moved our data into our data folder. There are ways to do this with code. So you can actually use a zip and unzip command. I'm not showing you that for now because I think many of us are probably more familiar with downloading something and then like dragging and dropping, whatever you're comfortable with. But no, as always in R, there's many ways to do this. So let's go ahead and move into the bringing the data in. And so loading the data is going to be look something like this. So I'm going to call this CSCI DAT. So this is our bioassessment data. So now we're actually using a command or a function, I should say, called read CS_CSV. And then here's where relative path names are great. So it has to be quoted, and I'm going to hit tab. I haven't even typed anything yet. I'm going to hit tab, and now you'll see it brings up all the files that live within my project, and these are relative. And that means that if I were to send somebody this same R project, the path would be the same on their computer too. So data, and if I hit enter, it puts data into there. And then if I hit tab again, it brings up all the files that are in that folder. And so for this CSCI DAT, I'm gonna highlight that I'm moving with arrow keys and hitting enter. There you go. So no typing involved, right? No typos. Makes it much easier. Great. So we have this, and I can enter this data, or I can run this command. And there we go. Now I have data. It tells me some information about this data. If I click on my environment tab, I now have something called data. And if I click on this little blue arrow, you'll see here's a whole bunch of information, right, about that data. So let's do the same thing for the ASCII DAT, which is an algal bioassessment index. And same thing, I'm gonna do quotes, tab, data, tab, ASCII, and run that command. So you'll notice typing gets a lot quicker if you use that tab autocomplete, okay? The other really cool thing we can do is we can actually look at this data visually, kind of in a way that we might do with a spreadsheet software or something like that, using view. So if now I have this object, notice I'm not quoting it now. Okay, so now this lives here. It doesn't need to be quoted. So I'm gonna hit view. Okay, now we've got this quite large data set, but the cool thing is I can, and you can readjust your windows however you want, but I can search within this for a given site. So if I start typing numbers in, it looks like, let's say 105 CR. Here's a site, station code 105 CR. It's already filtered to those sites for me, so I can quickly look. You can clear that, and you could filter or sort this based on the station code. So if you click on one of these columns, it'll sort the code alphabetically or reverse numerically, whatever it is you're sorting by, okay? So it's a nice way to sort of look at your data. Again, you can only interact with this data. You can't actually change it or type in it. This is just a way to view the data. Okay, all right. So the next main thing is we want to inspect our data and see what we've got here. We've got dimensions of CSI, I'll say ASCII data in this case. What are the dimensions? So how many columns and how many rows? And in R, the way it's going to return this, it's going to have the number of rows and then columns. And that's important for later on when we're trying to subset or filter data. It's always rows and then columns. And the same thing, information is here in your environment tab. You can see there's 2,585 observations and 3 variables, which are columns, okay? And I can click on the blue arrow and see each of these columns here has a different type of data. So character and numeric in this data set. And if I look in the CSCI data set, character, numeric, 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 character, okay? Okay, I'm gonna skip through some of this. Oh, column names. There's lots of ways to look at your data. You can use names to pull out just the column names if you kind of want to see what those are. So I can use names. You can use head to look at the first few rows of the data. Another really helpful one I find is the structure or STR of that data. I should be adding comments. So you can see if I run structure of the data, you can see that it spits out sort of the same information that's down here, but it gives you a lot of nice information about the data itself, like how many observations, how many rows, stuff like that, okay? All right, so let's skip down to data structures and think about this. Yeah, we can do data structures and then wrap up. Sorry, Haley, this is running a little longer than planned. But all right, so I'm gonna make a new section because this is kind of an important part about understanding what kind of data you have and what you're working with, right? So Control-Shift-R, and then we'll take a short 5-minute break and jump into the next few lessons with Haley. So let's talk about data structures. Save that. Okay, so in R, there's many formats to store our data. And so let's talk about some of those different kinds. And I mentioned them on the website here, but there's vectors, which are, vectors can be different types of data. So let's look at what's called a double vector, which is essentially like a numeric type. So it has a decimal. And so double var for variable, I'm gonna assign that. And then this is where the list comes in, right? So I can make a vector with this combine function. And for this, I have to use all numbers to keep it all the same. So R is pretty picky about a vector has to be the same kind of data, right? A list can be many different kinds of data, but a vector has to be the same type. And so if you think about every column in my data frame over here is essentially a vector because it's all the same kind of information. So here's a vector of double, which is, if I look down here, it's called numeric, right? Is a fancy way of saying double. For those of you that use ArcGIS, you might be familiar with that terminology. Integer is like whole numbers. So we can use integer, var, same thing, it's a vector. Here we can use this kind of interesting format that's L at the end of the number, which is essentially showing that it's a whole number, okay? And so by using that, I can then, whoops, sorry. Typos are great. So here's a good example on the fly. So I got this error, unexpected numeric constant in integer var, blah, blah, blah. And if I look over here, there's a little red X. And if I hover over that, it's saying unexpected token. And that's because if I look over here, I forgot a comma. Okay, so I go back, add my comma, hit enter, and voila. There we have now a integer variable, which is whole numbers, okay? And I believe you can do that actually without the L's, but the L's make it very explicit, which is good to be very clear. Logical vectors are true, false, so sort of binary options. And there's some kind of interesting, cool things that can happen behind the scenes with the way R interprets these. So true, false actually is true, false here, but behind the scenes, this is actually interpreted as 1 and 0, which is nice. You can use that to useful effect later. And then the last thing is a character vector, which is unsurprisingly character. And this has to be quoted. So characters have to be quoted. So we can say frog, dog, cat, right? It could be any number of things in here. Again, it's all the same kind of data though in this vector, okay? A way to quick check that is to look, check for the class of the data or vector in this case. So we can use class and I'll say check that and it says numeric. Great. So that's an easy way to check. You can check the length of a vector, which is essentially what this is doing. It's telling you how many observations there are, which is the length. In this case, a length of one of these, let's use our logical variables. There's 4, so I should get 4 back. Awesome. Okay, so these are all really helpful ways to look at your data. Functions can be used on vectors of data, and similarly can be used on vectors in a data frame, which is what the things we read in our ASCII dat and CSCI dat. So mean, we can try to take a mean of a character vector, but we don't get anything because there's nothing to take the mean of, versus if I try to take the mean of my double, I should get an actual number back, which makes sense, okay? So again, the type of data matters. You can add these together, you can play with them. So if I were to, just a really quick demo, you can add 2 sets together. If you mix data together, let's see what happens. So mixed dat, and I can add char_var plus my logical, and let's see what we get. And it's going to say, nope, can't do that, error, because you have non-numeric argument to binary operator. It's because I'm trying to mix 2 different types of data, okay? So I need to make sure I'm using the same type of data. So if I did the same thing, but for let's try the numeric and the integer, it probably would work, right? Oops, integer and double, okay. Yes, that worked. And so now I have this vector of numbers that's been added together. Okay, two-dimensional data, let's talk about really quick, and then I'm gonna shut up and pass the baton to Haley. And so mean, let's look at the mean of some of our data. So if you wanted to take the mean of our CSCI scores, right, which is this, why we're all sort of learning about these things for bioassessment, but these are called data frames. They're 2-dimensional data. So they're basically, like I said, columns of data with observations. And so if we wanted to take the mean of a single column, we would call the data frame first. And then there's the way to access the columns. Within that, you can use the $sign. And then you'll notice all these things pop up, right? And so if I flip down here and I try to take the mean of the CSCI score, and I run this, you'll notice there's an NA. And so why is that NA showing up? Well, there's probably some missing data, some NAs in that data. And so the mean function actually has additional arguments within it. And we haven't talked about that very much, but I want to bring that up really quick. So CSCI dat, I'm going to do the same thing, CSCI, comma, and this is now, I'm going to hit tab. And you're going to see a few additional options. And you'll see now, here's a few things, but na.rm is what we're going to use here, because it means there's probably some NAs in that data, and R can't calculate the mean because of those NAs. And so I'm going to say remove those using true. And now, if I take the mean, I should get an actual value back, 0.81. Okay, so that's one way to sort of look at your data. Another way, you can assign new data based on a function. So we could say sites and we can actually pull out a single vector. So if I just want a list of the sites, I can use, actually it's underscore, it's not even in here. Oh, here we go. We'll do station code. So this is the sites. And so now if I run that, I now have a list of the sites in my environment down here. And that's kind of handy if I wanted to send that to somebody or I wanted to look at that, I can run that and see like, okay, here's all the different sites I've got. Okay, so that's all the importing data. We're gonna actually jump into, Haley's gonna cover some more exciting stuff in the next section. Let's take a really quick break and come back in like 3-4 minutes. I know it's quick, but maybe a quick bio break. And yeah, I'm gonna stop there. Haley, how do you want me to pass the baton?
If you want to, I'll go ahead and if you want to stop sharing, I'll go ahead and share my screen and pull up the code. And then I'm going to turn my camera off for a couple minutes too. If folks in the chat just want to indicate before you go on a break, everything's going well, give us the green check mark. If you are panicking and treading water furiously, give us the red X. And our helpers are on standby in case you need some help in the break. All right, so for those of you that are following along with us on the website, just a quick reminder, we're going to be in this bicycle section here, data in, plot out, under wrangling data. So now that we've actually got our data into R, we'll be doing some fun stuff with it. All right. And can everyone see my code all right? Everything looks good?
Yes.
Okay, great. Okay, so the first thing we'll do is let's go ahead and make a new section since we're going to be working in a new part of the website. So again, you can either go to code, insert section, or the shortcut is Command or Control Shift R. And here I'm just going to call this wrangling and plotting. All right, so the first thing we'll be doing today is working in the dplyr package. So this is a package that's really helpful for helping you to basically reformat your data, examine your data, get it ready for whatever kind of visualization or analysis that you're hoping to do. So we'll say many of the functions below are part of the dplyr. Just to orient ourselves. So one of the first most helpful things you can do is known as selecting. So let's say we first want to select some chosen columns from our data set. Oh, and I need to go ahead and load my data first. All right, so if anybody's environment looks like this, they've come back and their data's in, make sure that you go back and find data here. Make sure your tidyverse is loaded and both your data sets are loaded in. So just to note, my screen might look a little bit different than Ryan's. I still have my script here in the upper left-hand corner, but now my environment is up in the right-hand side and my console's in the bottom left. All right, so let's say we're interested in selecting some columns from our CSCI data. So we're first going to give it a new name. So we'll call it dplyr cell 1. And we will select from the CSCI data frame a handful of column names. So that's what I'm going to type out here. So we'll say sample ID old, new lat, new long, and CSCI. So if you go ahead and run that, you'll notice that you have a brand new data frame, and that shows up in your environment. And you can either click on it, just as we did earlier, and it pops out in a new window that looks similar to Excel, or you can always go back out here and type view dplyr cell 1. And if you run that line, it'll do the exact same thing. But either way, you should generate a brand new data frame for yourself by running that. We can also take a look at the structure of that data set by typing head dplyr cell 1. And if we run that, you'll actually notice that some of the first couple rows of that data set pop up in your console. And so it'll show you how many rows you have, or excuse me, how many columns you have, what the format is. So that's what's in the sort of carets there underneath. And then in this case, the first 6 rows of the actual data frame. So those are just a couple different ways that you can examine the data that you've created. So let's practice another one. So let's say we want to select everything but CSCI and COM-ID. And in this case, we're going to be using the minus symbol, which indicates not. So here, we'll call it dplyr cell 2, select CSCI. Again, we're drawing from that same data frame, but in this case, we're going to be selecting everything except for the 2 columns we have specified there, CSCI and COM-ID. And if you run that, again, it should appear in your environment. And let's say we're interested in just taking a look at the top part of it. So we'll use that head function again. We'll comment this, examine top few rows of data frame. Just remind ourselves what it does. And if we run that, again, you should be able to see that in your console. And now you'll see it looks a lot longer because we have included far more columns in this particular data frame. All right, and then another cool thing you can do is select columns that contain the letter C. So you don't necessarily have to select by column name, you can select by certain values or certain characters as well. So we'll call this dplyr select 3, and I'm going to select from that same data frame, but instead we're going to say matches C. And if you run that, again, should pop up in your environment, and we can examine it in our console by typing head dplyr underscore sub 3. So now it's only selected columns with a C in it, which in this case are station code, COM-ID, and CSCI. So this can be really helpful if you're dealing with a tremendously large data set, but you're really only interested in certain parts of it. All right, so the next thing we're going to learn how to do is filtering. So let's say we're interested in getting CSCI scores greater than 0.79. So in this case, we're going to call it our new data frame, dplyr filter 1. And now we're going to use the filter function instead of select. Still pulling from that same data set, CSCI dat, but instead CSCI is greater than 0.79. So here we're calling from the CSCI column, and we're searching for values within that column that are only greater than 0.79. And let's say, let's do view, dplyr filter 1. And we can examine in a new window. And if you go to the CSCI column here, if you were to sort, you should be able to see that none of the values are below 0.79. Great. And let's say we want to get CSCI scores above latitude 37 north. So we'll do dplyr filter 2. And this time we're going to filter CSCI data, but instead call from the latitude column and have that equal to greater than 37. And again, if we take a look at that, now in the new latitude column, you can take a look and see that all the values should be greater than 37. Great. And let's say we're interested in using both those filters. So in this case, dplyr filter 3, we're going to filter CSCI data and do CSCI is greater than 0.79, and there's our logical operator, new lat is greater than 37. So this should allow us to do both of the operations that we did individually in the rows above. And you can double check those if you'd like in new lat column and the CSCI column as well. So just a quick note for if you're interested in using some of those logical vectors, logical operators, the and symbol signifies and, as you might expect. This sort of straight up and down line signifies or, and then the double equal sign signifies equality. All right, so I'm going to pause there for a moment. If folks want to give us the green check mark or the red X, let us know how you're doing, if you're struggling with anything. I'm going to pause here for a moment. I see the green check mark's coming, but want to give them a moment to get in. All right, so the next helpful function we'll cover is the mutate function. So this will be mutating. And what mutating actually allows you to do is to create new columns within your existing data frame. So you might have done this in Excel previously, where you have a function that you're able to apply to a full column. But what's really nice about doing this in R is that you can see exactly what you've done and go back and edit it in the future, or it's just a little bit more, it's just easier to collaborate and share your code, and so folks can see exactly what you've done to create these new columns in the future. So let's say we're interested in seeing some of the observed taxa from our data set. So dplyr mutate 1. And in this case, we're going to use the mutate function. It has a similar structure. So we first call in the data set itself. And then you're going to name the new column you're creating. So in this case, we'll call it observed. And then you want to provide it with what's going to actually create that column. So in this case, we're going to take values from the OE column and multiply them by values in the E column to create our brand new observed column.
Haley, can you save real quick?
Yes.
Thanks.
So again, if you take a look at that, typically when you create these columns, they'll pop up all the way at the end of your existing data frame. And here you'll see it's using the name that we just created, observed. And what it's doing is it's multiplying values from your OE column by values in your E column and presenting them here in your observed column. So here we'll say create new column named observed, just to make it explicit. All right, so let's say instead we want to add a column for low, high CSCI scores. So instead we're going to do dplyr mutate 2. Again, mutate CSCI data. And let's instead call this CSCI cat, or sort of a category column. And here we're going to use what's known as an if-else statement. So we'll type if-else. And let's type this out and then I'll talk you through what it means exactly. So CSCI is less than or equal to 0.79, low, high. All right, so essentially what we're doing here is we are creating a statement where we're going into the CSCI column, and if the value is less than or equal to 0.79, then in our new column that we're creating, CSCI category, it will print low. If the value is not less than or equal to 0.79, it will print high. So typically, if you want to think of it this way, if-else statements are essentially examining for a certain criteria. And if that criteria is met, then it'll print this. And if that criteria is not met, then it'll print that. If anyone has any questions about that, I realize it might be a new concept for some folks. Feel free to ask questions in the chat. These come up quite a bit, and they can be really handy when you're trying to parse data sets by certain rules. All right, and then just a couple more helpful functions that we wanted to share with you today that we thought would be good for you to have in your back pocket. Let's say you wanted to arrange the data by CSCI scores. So in this case, I'm going to call it dplyr_arrange. Using the arrange function, we'll arrange the entire data set, CSCI data, by CSCI column. And so again, let's take a look at it in our console, just getting some more practice using that. dplyr arrange. So now you'll notice here that it has automatically arranged the data set based on the CSCI column, starting with the lowest values, working its way up. So it's rearranged that whole data set around ordering itself by that CSCI column. And another helpful function is the rename. This is especially helpful if you happen to import your data and your column names import as gibberish, which is totally normal. I'm just going to put a note here. The format, because it's a little counterintuitive, is going to be new name, and then you provide the whole name. So here we'll do dplyr RNM. And in the rename function, first we're going to again tell it CSCI data is the data set that we're interested in. And let's say we want to rename two different columns. So the new name we want to use is lat for latitude. We do not want it to be called new lat any longer. And the new name for longitude that we're interested in is long. So we're going to be replacing new long. So again, we've got our new names for the columns first and our old names for the columns second. Let's go ahead and run that. And again, if we use this head function, it should display in our console. And you'll see those columns that were once new lat and new long are now renamed to just lat and long, which is just a little bit easier to type out and call. All right. So the next helpful function that we wanted to introduce you all to, and this is particularly powerful, is piping. And so just so folks are familiar, a pipe is this funny looking collection of symbols. So it's %, greater than, %. And essentially what it helps you to do is it helps you to string together a whole list of functions. So you can just pass the data through them all in a row instead of having to create all these different new data frames in each line. So let's do one just to practice. and then we'll have a little exercise for you. Practice it on your own. So let's say we want to create a new data set. So we'll call it CSCI_new. And the first thing when we pipe is we always have to provide the initial data set to use. So again, we're going to use CSCI dat. And I'm going to add a little comment in this line and say here we use the original data set. And then dot, dot, dot. If you hit enter on the next line, don't panic if that little red X pops up. It's just telling you your code isn't finished. That's okay. So in the next line, let's say we're going to select only the CSCI, COM-ID, and new lat columns. And again, we add this pipe symbol. So you'll notice we didn't specify the data frame here in the select function, but that's because we're piping, we already put it up here in the first line. So R already knows what data frame to pull from. So here we're going to select only CSCI, COM-ID, and latitude columns. All right. So on the next line, let's go ahead and impose a filter since we know how to do that. So let's say we want to filter only by new latitudes that are greater than 37. Again, pipe symbol. So here we're filtering for latitudes of 37. And the final thing we're going to do is create a new column, mutate, CSCI cat, and we're going to use that if else statement. If else CSCI less than or equal to 0.79, low, high. So here we are creating new column with categories according to CSCI values. All right, so what we've just done is we're creating a brand new data set using our original CSCI data set. We pipe that through to the next line where we select only a handful of columns. We pipe that through to the next line where we filter by latitude. And then in the next line, we create a brand new column. So if you go ahead and as long as your cursor is anywhere within this code chunk, you can go ahead and hit run. And you should have a brand new data set pop up in your environment. If it doesn't, check to make sure that you have pipes connecting each of your line statements here, because that might break it. All right, and I'm just going to add a little note because it's helpful to see. Note, we do not need to specify the full data set in each call since it is identified at the very beginning. And that's the beauty of piping, is it helps you knit things together in a way that allows you to track every step that you've done, while at the same time keeping it as streamlined as possible. So can folks give me either a green check mark if they're following or a red X if they're having trouble with this particular pipe chunk of code? All right, so I see some folks are still working on it. So I'm going to pause here for a moment, and if you all want to navigate to the website, there is a challenge for this particular section. So in data and plot out, wrangling data, and if you scroll down, some cartoons in here. So if you scroll down to challenge 4 here, go ahead and see if you can work through using that same piping technique to create a new data set called ASCII new. And for those of you that are still working on it, please feel free to post questions in the chat if you're struggling with the pipe. If you've got a handle on it, you can go ahead and give the challenge on the website a try. And I'm going to redisplay my code here just for folks who might need it. So again, these pipes are really helpful when you're trying to use a raw data set that you've imported into your R workspace, but you know you need to do some transformations and likely add some additional columns or filters or rearrange like we did based on the CSCI scores prior to any sort of analyses or visualizations that you're trying to run. All right, and so if any of you are working on that challenge, I'm just going to walk through it right now. So this is the challenge number 4 based on from the website. So what it's asking us to do is to create a new data set. So we're going to go ahead and instead we're going to be working with the ASCII data this time. And the first thing it asks us to do is, well, first we need to pull in the data. So ASCII data, again, using the original data set. And then we want to select only the site type and ASCII columns. So we're going to select ASCII site type. So here, selecting columns of interest. And then it requires us to filter by reference site. So here, we're going to impose a filter on the site type column. And here we're going to use that double equal sign. So for site types that are equal to reference, because it's a character, we're going to put it in quotes here. So here, filter for reference sites. And then at the end, it asks us to create a new column. So that's where we'll bring in our mutate function, where we're simply going to take the ASCII scores and multiply them by 10. So we'll call our new column ASCII_10. You can name it whatever you like. And we'll take values from the ASCII column and then multiply them by 10. So here we create new column with ASCII scores times 10. All right, and so if you type in view, ASCII new, or you can simply click on it in your environment, you should have this brand new data set that's much tidier and tinier probably than your original data set, where you have your ASCII column, your site type. You'll notice that only reference is included here as we specified, and then all the ASCII scores multiplied by 10 in that final column. All right, so that is the end of the wrangling section. We only have one more thing we're going to do today, probably the most satisfying and fun thing. We're going to plot the data. But I'm going to just ask folks one last time before we move on to the plotting to give us a green check mark if things are going well, red X if they're not. And if you're following along, we're going to be navigating to the plotting with ggplot page on our website. So it should look something like this, plot data. So ggplot is just one of the many potential packages you can use. It's probably the most commonly used, but it's a really nice structure for creating clean data visualizations and adding various customizations and features to them. So I'll just add in a comment here. Today, we'll use the package ggplot2 to plot our data. So the first thing to keep in mind whenever you're creating a plot, specifically in ggplot, is that there are 3 main components to any plot. The first is the ggplot call itself. So, so this is where you actually tell R to make a plot. And that's where you specify which data set you'll be using. Geom call tells R which geometries to use. So we'll be using a couple different ones of these, but essentially it just tells R what kind of plot to make. So do you want a scatter plot or a box plot or a violin plot? That's all going to be specified by the geom or the geometry. And then finally, we have the aesthetics call. So these allow you to customize your plot. So this is where you'll specify your axes labels, how you'd like things colored, and then you can really go down the rabbit hole with this. But those are the 3 main parts of a ggplot. All right, so if we were to sort of break it down, an empty base plot or graph might look something like this. ggplot and the data, in this case, again, we're going to be using the ASCII data. So if you run that line, don't panic. If all that pops up in your plots panel here on the right-hand side is just a gray box, nothing. Because all we've done is we've told R what data to use, but we haven't told it how to use it. So let's go ahead and do that. So let's say we're going to use today a scatter plot. So here, the data we'll be using is ASCII data. And in ggplot, the way that you add lines together is you simply put a plus sign in between them. So we've specified the data, and then in the next line, we'll specify the geometry. So in this case, geom point, geom underscore point, is going to create the scatter plot. Now, if you run that, you'll notice that we get the error that says requires the following missing aesthetics. So ggplot can't actually move forward unless you tell it exactly what you want on each axis. So let's go ahead and tell it what we want on the axes. So we'll say specify aesthetics. So here, again, ggplot data ASCII dat geom underscore point. And then within the parentheses here of the geom point, we're going to tell it mapping equals aesthetics. And this is where we specify what goes where. So X is going to be site type in this case, and Y will be the ASCII scores themselves. All right, so if you go ahead and run that line, and again, because it's 2 lines of code, as long as your cursor is anywhere in these 2 lines of code, you should be able to run that. And when you run that, you should see a plot pop up in your plots pane. If it's not, contact one of the helpers and see if they can help you resolve it. But essentially what you're doing is you're just feeding in this ASCII data set and telling it, I would like a scatter plot where site type is along the x-axis, which is true, we have our categories there, and all of our ASCII values are going to be along the y. And it automatically usually creates the sort of bounds of the axes unless you specify. Great. So let's try to make a different kind of plot. So let's go ahead and create a box plot instead, which some of you may create quite a few of in your daily lives. So in this case, instead of just creating the ggplot, we're actually going to save it to a name so that we can call it in the future. So I'm going to call this ASCII box. And it takes very similar calls. So we'll say ggplot And in this case, data is ASCII dat +sign. And on the next line, we're going to specify the geometry. This time, instead of point, it's going to be box plot. And our aesthetics need to go inside the parentheses there. So mapping, aesthetics. Again, we'll put site type along the x-axis and ASCII scores along the y. And now, let's say we want to customize our plot to make it just look a little bit nicer. Let's also add some labels. So the call for that is labs. And here we'll label the x-axis as site type. And then you want to put a comma in between each of your labels. We'll do a y-axis label of ASCII score. Let's add a nice title, CABW Workshop figure. And I'm going to add today's date as well. And I think a good habit to get into is to always include, if you can, if it's appropriate, a caption that attributes where you receive this data from, especially if it's not your own. So in this case, we'll say the data source in the caption. So here, just to add some notes here, so this is the initial data input on this ggplot line. Here we specify the axes in the geom and geometry. And then on all of these lines here, add appropriate labels. All right, so as long as your cursor is anywhere in here, if you go ahead and run that, you'll notice this time that the plot does not pop up in your plots pane, and that's because we saved it to this value ASCII box. Instead, you'll actually notice that it should appear in your global environment. So in order to see it, all you have to do is call it in this next line, and if you simply run ASCII box, it should pop up instead in your plots pane. And you'll notice we have our nicely labeled title and axes. And if you feel like things are getting a little bit squished in this pane here, this zoom button is really helpful. So if you click on that, you can go ahead and blow up your figure and take a look at it in a slightly larger way. And then most importantly, let's go ahead and save our plot, because it doesn't do as much good if it just stays in R here. So the way that we save our ggplots is using, unsurprisingly, the function ggsave. And so the first thing we do is we specify what we want this plot to be named. So I'm going to call it ASCII_boxplot, give it a fairly simple name. And typically I export mine as PNGs. You can certainly do them as JPEGs, as TIFFs. There's various other formats available. But for today's exercise, we're just going to do it as a PNG. And note the double parentheses here. So we've got the double parentheses around ASCII box plot PNG, and then between the last two, we'll add a comma. On the next line, you want to specify the path of where it's going to go. So in my case, it's simply going to be data, because that's the folder that within my working directory it's going to be going to. But I'll just add a note here to be sure you specify the path. And then you can also control what size actually it outputs. So in this case, I'm going to give it a width of 25 and a height of 15. And in this case, the units we're going to be working with are centimeters. Again, you can also specify this to be inches if you prefer to work with that instead. And so if you go ahead and run that, making sure that your path is specified correctly, you should be able to save the most recent, whoops, I'm gonna have to fix my path, but you should be able to save your most recent output. All right, and just a note here, ggSave function saves the most recently created plot. So unless you specify it in the actual ggSave function, it's just going to call up and save and export your most recently created plot, which in this case is our ASCII box. All right. So I'm going to go ahead and pause here because we have reached the end of the content for today. Actually, ahead of schedule is amazing. And just give everyone a moment to catch up, make sure that you've been following along all right on the website, and give us a green check mark if you were able to work through the end of the box plot, or a red X if the export isn't working or the plot isn't displaying as you anticipated. And again, feel free to message any of our helpers for questions if you're having issues with anything in particular. So for those of you following along on the website, the last part, oops, excuse me. The last part here is displays the box plot that should have appeared with your box plot chunk code there. And this here is the saving code. So you'll notice here we've just left this as kind of a placeholder. So again, make sure that the file path is referring to the correct location where all of the remainder of your files are saved on your computer. Mine's just a bit funky since I'm working out of the Dropbox today. But I definitely would suggest that you take a moment at the end of today to check out the original ggplot website. There's lots of really amazing examples. We just covered 2 different geometries today, but there's oodles of them. And you can customize things with color palettes, which we'll learn a little bit more about tomorrow, and various panels. And tomorrow we're going to get much more into plotting as well as mapping spatial data. All right, so I'm going to go ahead and stop sharing my screen. And if folks have additional questions, feel free to put them in the chat or contact one of our helpers. Or if you'd like to either email Ryan or I at the end of this as well, we'd be happy to answer any of your questions at the end. We really appreciate everybody's patience as we work through this new virtual format. And it's doubly challenging to learn code over Zoom. So congratulations to all of you for giving it a go.